Hello, my name is James Overton, and I'm going to present to you today on the OntoDev suite, which is a collection of ontology and data integration tools written by me and my team, especially Rebecca Jackson. So we're really trying to help scientists make better use of ontologies. Ontologies are great, but sometimes they can be tricky to use. Where do we want them to use those ontologies? Well, in their papers, in their protocols, in their tables, in their databases. Basically anywhere you want to talk about some kind of scientific term, let's use the ontology term, and then it'll help with data integration further down the line. We want everybody to use these things, but especially kind of early career students and postdocs, and we want to meet people where they are. So if they're using Python or JavaScript, let's get them to use ontologies with their Python and JavaScript in their notebooks, whatever Linux, Mac OS, Windows, and let's get web-based tools to make it easy for people to just jump in and make use of ontologies. So my outline involves like a distinction between tables and trees, branches and workflows. I'm going to mention some of the best-in-class tools that we use, such as Git and GitHub, but also other tools that we built. And I'm going to give a whirlwind overview of each of these things, but there's links to all of them, and you are welcome to learn more about them. They are all open source tools, free to use. So my general philosophy is to use tables for editing. They're easy to think about, they're easy to program with, there's lots of mature tools for working with tables, and in particular, tab-separated values, TSV, is good for version control. On the other hand, trees are great for browsing. Even simple hierarchies are very useful. RDF is flexible, extensible. OWL brings a lot of logical power. So the tools I'm going to show you today are designed to move back and forth between tables and trees, and use ontologies in the tables and the trees. I also love Git branches, letting people work in parallel and then merge their work together with pull requests. GitHub is great, but there's lots of other good tools like GitLab, and then command line tools, GitHub Desktop, all these things. And then I really believe in repeatable workflows, where we have a bunch of small tasks connected in a network, and we should define that in another version control format. And we can package that up in Docker. And I like to give people local and web-based options for all these things. So first, let's talk about tables. So Cogs is a tool that lets us synchronize a Google Sheet with a directory of TSV files. So a bunch of TSV files in a directory, and we can push them and pull them back and forth to a Google Sheet. Google Sheets are great for collaboration, rich editing, filtering, and TSVs are great for version control. They're easy to read and write from software. So we build on a great Python library called gspread, and we copy the git command to initialize, add, fetch, pull, get status, diff, push. And we use TSVs for error messages, comments, formatting, formulae, so we can output things like comments, error messages such as this one. And one way we do that is with what we call a standard message table, where we say which table we're talking about, which cell, the error level, maybe the rule that we've got, and what that is. And then we can have a little comment on each of the errors. This makes it easy to find the errors and fix them in your spreadsheet. Axel is like Cogs, but it uses Excel files. And Excel files can handle larger tables, suits different kind of audiences. And again, we build on a tool called OpenPyXL. We also have general needs for validating all sorts of different tables. And our tool called Valve is a validator that's configured in tables. So you have a table like this that's saying what each of your columns are, what their data type should be, what their structure should be. And we've designed this for kind of iterative data cleaning, where we allow you to still have errors in your data, still have problems as you're going through and fixing it. We don't require you to make everything valid all at once. Sprocket builds on top of Valve and these other tools to give you a web-based interface for viewing those error messages, and then also for editing in HTML forms with the validation all interactive. Our tree tools, Robot is our most famous tree tool. We've been building it for about 7 years, and we've got about 2,000 commits from the community. Robot is focused on the open biontologies community, but it is generally useful for ontology development. And Robot does somewhat bridge the gap between tables and trees, because it works with OWL for trees, and then it also works with templates, imports, reports in tabular formats. We've recently built a tool called LDTab, which imports an OWL file into a SQL database and has a couple of neat tricks for encoding complicated OWL expressions in JSON. And so LDTab lets you read an OWL-RDF file into SQL, query and edit it in SQL from any language that will talk to a SQL database, and then write back to OWL and RDF. Wiring is a library that works with LDTab to make some of these conversions between different languages. And so we can encode into a JSON format, but then render that out to Manchester strings with links, like you'll see in some of the other examples. Gadget is our Python library, which is a web interface for viewing, searching, and editing those LDTab tables. And so we've been able to build an Ontology browser that works locally. It's very lightweight and fast, and then it also allows you to edit in interesting ways. And then the workflows are tools that bring all these things together. So we have Nanobot. Nanobot is specifically designed to connect the tables and trees together in the ways that I've been talking about. So on the table side, we have the Valve table validator and Sprocket web interface. And on the tree side, we have LDTab for loading in OWL files, and then Gadget for working with them with a web interface. So I'm going to show you a few different things that you can do with this. One of them is to start with an ontology tree and then jump to the template row that defines that term. And another one is to browse source ontologies and then add or edit the import table that controls what's being imported. So here is our Nanobot editor, and we have a normal ontology browser where we can browse through the tree in all sorts of different ways. There's the classes, object properties, individuals, and then here we have the annotations and also the logical definitions and stuff. Up here we can grab lists of all the ontologies and also lists of all our tables. And if we've got a term like analyte assay and we click on this edit button, we jump to a row in the assay table, which is a set of robot templates for editing this particular term. And so we get our table editor with all our validation and a whole bunch of other cool things like autocomplete and ontology-driven autocomplete and validation that I'll build on top of this. And kind of likewise, we can go into our list of ontologies. Say we're working with the OB ontology, which imports a whole bunch of ontologies. And so here we're looking at a cell ontology. There's an epithelial cell. And here we are going to edit the import definition in our import table. We could also find a new term and add it to our import table. So we jump over to our import table, and again we can see the source term, say where it's going to be imported into the ontology, validate it, and update our table. And then our tools such as Robot can take that import table, rebuild the tree structure, and get back to your tree browser. So all of these tools are designed to move back and forth between tables and trees, allowing you to use ontologies in a bunch of different places. And I'm showing you how to use these tools to edit ontologies themselves. OB is an ontology. Many of its terms are defined in templates and tables. But it does work for data sets, so it's designed to be scalable, and it does work for large tables of data that might use ontology terms in one way or another. Now, Droid is another workflow tool where, in particular, it's a web application for branch-based development of ontologies. All the tools that I've showed you so far, you need to run locally on your local computer, but Droid is a way of packaging up those tools and letting them run on a server. And so the first step is to authenticate with your GitHub credentials, and to make changes to the project, you need to have write access on the GitHub project. And then you can create different branches inside that project. Each one of those branches runs inside a Docker container, so it can have whichever software you need installed into it. And then when you're looking at a particular branch, you can do a bunch of things. You can use common version control operations to update the branch, check your diffs, create a new pull request, and push your commits back to GitHub. And you'll also see that there's a set of curated workflow buttons and links that are a kind of customized set of operations that you might want to run in your workflow. Droid is actually built on top of the venerable GNU Make program for running tasks. It uses Docker, and then it talks to GitHub in each of these steps. So here's an example of Droid. I've logged in with my GitHub account. I'm looking at all the different projects. Each of these projects is set up on GitHub. And then I'm going to pick this first one. And when I look at the MRO project, I see that there's a number of different branches. Some of them have been checked out locally. Some of them I could check out myself. And each of these branches is running inside a Docker container, and I can see its Git status. So if I click on the demo side link, then I get a bunch of the things I just told you about. Over here on the right is the version control operations. They've been boiled down to the simple ones that I think are the most important. So checking your status, fetching for updates, and then making your commits and pushing the changes back to GitHub, where they can plug into the rest of the workflow that you've designed. And then on the left here is a customizable set of buttons for doing things like updating the templates or running a rebuild process, refreshing some of the upstream ontologies. But in particular, I want to point out that this button here, it's with a rather silly name, lets you switch back into the nanobot tool that I just showed you. And so from inside Droid, you can run that nanobot tool to view all the different imports, all the tables, all the upstream ontologies, and then make changes that will result in a pull request and go back up to GitHub. Here's an example where we click the diff button and we see, the diff report. So Droid is running this command for us and showing us the console output. So Droid is designed to make a kind of zero install option for running all the tools that I've been mentioning. And then the next step kind of in development is Drone. So whereas Droid is designed for trusted contributors who are allowed to run expensive processes like reasoners and massive imports, the idea of Drone is to allow for public contributions on kind of a smaller scale. They would again authenticate with their GitHub credentials, but no special permissions would be required. They'd be allowed to use the nanobot interface I just showed you, but they wouldn't have access to expensive build processes, until they become a trusted developer. And the idea is that they could use nanobot to make changes to tables using the table editor with all the validation tools, and then create a pull request, just like anyone in the public can create a pull request on your public repository. And so once they've created that pull request, they're once again in your workflow, and you can run your GitHub actions. You can merge the pull request. You can also go maybe to Droid and pull that pull request into Droid and work with it in Droid. So I've just presented a whole bunch of tools, a whirlwind tour of the OntoDev suite, and here's how they all fit together. So we started with data in Excel files and Google Sheets and TSV formats. The TSVs in particular we want to store in version control, and we also have RDF and OWL formats. And then tools like Axel pull Excel files in and turn them into TSV. Cogs works with Google Sheets and TSV. Valve works with TSV to validate it and load it into a SQL database. And then Sprocket will give you a web interface for working with those SQL tables and the validation tools. On the other side, we have Robot for working with OWL. We also have LDTab and Wiring for working with OWL, and Gadget, which is our lightweight ontology browser and editor. And Nanobot brings those two together so that we can move back and forth between trees and tables. And Drone is in development to let that work as a general web interface for the public to work on your GitHub project. And then Droid brings together things like Make and optionally Nanobot web interface as well. And again, talks back to GitHub so that you can go full circle. You can go from your data, start in GitHub, make the changes as required, and then push it back up to GitHub through your issues, through your pull requests, with all the GitHub authentication that you need. I want to thank a lot of people, really too many people to mention here. We have the Notion team who've worked with me over the years, The La Jolla Institute in particular have been very generous and I've worked with them for a decade. There's the general open bio-ontologies community, and then there's a number of different clients who have supported this work in different ways over the years, such as the Immune Epitope Database, Chemical Effects on Biological Systems, LBNL, MBLBI, Critical Path Institute. Almost all of this funding has come through the National Institutes of Health in one way or another, and I'm very grateful for their investment in open source tools and technology. So please feel free to get in touch with me by email or go to ontodev.com, learn more about our projects, and thank you very much.